going to at least post something that they can see. Okay, so here we go. So we're going to take a look at a set of linear numbers. We'll just do a bit of a review from yesterday. And let's say that you had the numbers 3, let's see, 5, 7, and then you're kind of like predicting the next two numbers. So this pattern is fairly straightforward. We talked about the word common difference yesterday. So the common difference, CD, is basically the difference between two consecutive numbers in the pattern. So if you look at this as being term 1, this being term 2, this being term 3, then if I take term 3 and I minus term, say, 2, those are two consecutive numbers, I get 7 minus 5, which is 2. And I could do that for term 2 minus term 1. 5 minus 3 is also 2. And what I would notice is that basically I'm just adding 2's every time I do this. I'm adding 2, I'm adding 2, and then I would, of course, add 2, which would make this 9. And I add another 2, which makes this 11. So this is linear in that every time you move along, you're basically increasing by the value of 2. And in yesterday's video, we talked about how do you actually generate a formula from this? How do you create some kind of equation? And so we could say that Tn, the term you're looking for, and n is the number of the term, would be equal to, well, what are we doing? Well, we're adding 2. So basically every time we go up by n by 1, we increase by 2. But then we have this b value we talked about yesterday that is sort of your starting point on the what's going to turn out to be the line, actually. And it actually turns out to be T0, the 0 term here. But let's solve it algebraically. So let's take term 3. So we can use algebra to solve this, and we would say that term 3 is 7. That's what it says in the patterns. That's term 3 right there, 7. And I'm going to go 7 equals 2n plus b. But if I'm looking for term 3, then my n value is 3. So I'm going to put a 3 in here. And so now I get 7 equals 2 times 3 is 6 plus b. Let's subtract 6 from both sides. So 1. And so I get b equals 1. And once again, if you didn't see the video yesterday, I would encourage you to maybe watch that and then maybe come back to this video here. Okay, so b is 1. Now, if you also think about it this way, if you're adding 2 every time you go this way to get to the next number, then you'd be subtracting 2 if you went backwards. So if you're at 3 and you go back 2, then you're going to be at 1. So this equation now, we get a new equation called Tn equals 2n plus our b value of 1. And you might be saying, well, what if you didn't do T3, you did T4, T5? You actually would get the same b value. It wouldn't change. It's the same b value. Okay, so why is this related to what we're getting into today? Well, today we're looking at is graphing a linear equation or system. I'm gonna call it a function. That's sort of the fancy math word for it. And although you may not know what the word function means right now, we will talk about that in later videos. So now, when we graph something, you can thank René Descartes for this, a French mathematician. We usually graph it on a number plane where we have these 4 quadrants. So quadrant 1 was here, quadrant 2 is over here, quadrant 3 is down here, and quadrant 4 is on the far side. And when we graph them, these lines, this line here goes up and down, this line here that goes back and forth, they're given certain letters. And in the video yesterday, I believe I made this the T line and I made this the N line. But I'm going to erase those now. More generally, we refer to the horizontal line as the x-axis. So this is the x-axis. And the vertical line is referred to as the y-axis. Now, you might call those different things, like in a physics class or a biology class. You might have different meanings for those. But they are in mathematics referred to as the x and y axes. And then our equation, where is it here? Our equation here, we actually relate y equals 2x plus 1. So this equation I've just written here has y's and it has x's, and we can now relate it to this graph here. And we can see the pattern of numbers is increasing. Let's draw a line around that. So it goes from 3, 5, 7, 9, 11, and we just keep getting bigger and bigger and bigger. So if you guys have some graph paper, I might give you just a minute to get that organized. If you don't, you can just draw this freehand if you want. But I'm going to import a grid I used over here. So this is part of yesterday's lesson. If I can see if I can copy that over. So let's see if I can control copy. Perfect. Okay, there we go. Okay, so that's gonna work. Okay, so I'm just gonna drag this up here. Scroll down a bit. Okay, so let's make sense of this now. I'll shrink this down a bit. So here we have this equation 2x plus 1, and what our goal for today is if someone gave you this, if someone gave you this equation here, then how would you graph it? How would you actually draw this picture here? Okay. Now it's referred to as being linear. We'll show you how you know that, by the way, in a second here. It's a linear equation. And linear equations basically form lines. So they form a straight line. And so what I'm going to do is I'm going to ignore this right now. I'm going to ignore that and go back to our pattern of numbers. And so I notice it's 3, 5, 7, 9, 1. And it's T1, T2, T3. So I'm going to plot those points on this graph. So I'm going to say when my x value is 1, this is my x values. So my x values are 1. My y value would be 3. And when my x value is 5, sorry, my x value is 2, term 2, my x value is 5. My y value is 5, sorry. And when my x value is 3, my y value is 7. Now, if you're not sure where I'm getting these numbers, I'm getting them from this initial pattern we started with, these numbers here. And notice that the 1 here I've written right there, we didn't have that to start with. That wasn't what was given to us. We're just using 3, 5, 7. So just looking at these 3 lines, or these 3 points, it seems like they do fit on a line, actually. And if I was to connect the dots, they're linear, so they go up, 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 up. That will just keep going. You can kind of see that it, if it follows this pattern, it should go to 9 next, I think, if we were to extend the graph. So that's 5, that's 7, that's 1, 2, and 3. But if you were to go backwards, notice that it would go, I'll just use a different color here. It goes over 1 and up 2. Goes over 1 and up 2. So it should go down 2 and over 1. So if I extend that line, it goes through there, and I guess I go down 2 over 1, down 2 over 1, down 2 over 1. And this line keeps going down, 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 down. But what I wanted to draw your attention to is this point right here. That point we call the y-intercept. And it's the place on the graph where the line goes through the y-axis. So remember we said that the x-axis was horizontal and the y-axis is the vertical line. And you'll notice that in our equation here, if you look at the equation we got, this number here, that's 1. That's the value that you seem to start from. So we say we start at 1, and then we seem to go over 2, up 1, over 2, up 1. So how would you know that if you just were given this equation here? Like someone just said, well, there's the equation for the line. How do you know how to draw the line? Like how would you draw it? Well, one way to do it is to start at the start place, which is this 1 here. That's where you start from. So that's the y-intercept. But then the question, I guess, would be, well, what would you do after that? Okay, so you find 1, you put 1 on the diagram, and then what do you do next? Well, if you look at the next number that's given in the question, you have this number here, 2. And so if I write the number 2, what would that be if you wrote it as a fraction? So I said, I want you to write that as some number over another number, but the value is 2. Well, the easiest way to write that would say 2 over 1. Now look at the red lines I drew on the picture here. We said you went over 1 up 2, over 1 up 2, over 1 up 2. And that's where that comes from. Now this is referred to as the slope of the line. So slope, you might think of slope like a hill has a slope on it, or a roof has a slope on it. And the bigger the number is for the slope, the steeper the roof is. So if your number there was 5, you would have gone up 5 over 1, up 5 over 1. So now I'm kind of just sort of showing all this in a jumbled mess here. So we're going to do a separate question, but we're going to use these techniques. But what I want you to make note of is you want to start with the y-intercept first, that value first, and then you want to move on to the slope. So that's kind of the order of things. Don't do the slope first and then try to find your y-intercept. So let's sort of shrink this down. I'll scroll up here. If I can scroll up here. There we go. Okay, let's try a separate question. And I'm not even going to draw it yet. I'm just going to write the equation as y equals 3x minus 2. So I want you to think of what number here is the y-intercept. And what number here is the slope? Because there's two numbers here. Which number represents the slope and which one represents the y-intercept here? Well, the slope is the first number, actually. This is the first number. It has to do with the slope. And the second number has to do with the y-intercept. So the slope would be 2. But I would just get used to writing that as a fraction. And I would say, well, it's just 2 over 1. 2 over 1. And then the y-intercept is negative 2. So your line should go through the y-intercept at the value negative 2. So let's see if we can draw that, okay? So, Control V. There we go. Okay, so there's our graph. And I want you guys to see if you can draw that. Draw this information. So the first place we start at is the y-intercept, okay? So is the y-axis, is it the horizontal line or is it the vertical line? Well, the y-axis is always the vertical, and then the x-axis is always the horizontal. So we're going to go through negative 2. So negative 2 would be here. And now we have to start at that point. That's our start point. I call it start point. And when we start at that point, our slope now should be 2 over 1. Now notice it's a positive number. So when it's positive, the line's going to always look like it's going upwards as you go to the right-hand side of the graph. So basically, we're going to go over, I'll use a different color here. We're going to go over 1, and we're going to go up 2. So I'm going to put a point there. And then I'm going to go over 1, and I'm going to go up 2. And I'll go over just one more here. I mean, once you get 3 points, you're probably pretty good once you have a ruler to connect the dots now. Okay, so you don't need to show all the points, but you need to probably show 3 points, I would say. And then if I try to connect the dots here, if I get my ruler to stick, sometimes my fingers stick to the screen and drag the ruler. That's pretty close there. Okay, so I'm going to draw my line through that. Okay, so there we go. So our line would look something like that. Okay. Now, some of you guys might be saying, well, 2, could you have written that as a different fraction? Like, could you have said it's, 6 over something? So maybe you go 6 over 3. And you can do that if you want. I would encourage you to just put it over 1. It's easier. But you would still be right if you went to the y-intercept and you went over 3. So 1, 2, 3. Then you're going to go up 6 units. 1, 2, 4, 3. So that's 6 units here. So basically, if you go this way, that's over 3, and then up 6 units. So 3 and 6, or 1 and 2. And so it doesn't matter what number you picked. If you picked 10 over 5, it would have given you the same slope in that case. I just preferred making it over 1. It's easier to count that way. Okay, so the first step is always to find the y-intercept, and the second one is always to find the slope. So why don't we use the same grid? We'll use the same grid here, and let's graph this linear equation. And we'll say x, example, y is equal to negative 2x plus 4, say. So why don't you guys take a second to see if you can sketch that, graph that system there. And if you guys have any questions, feel free to unmic yourself. You can always ask if you're not sure. Okay, so once again, the order of things is you want to do your y-intercept first, and then you want to do your slope. Okay, so my y-intercept is the last number, so 4. And my slope is negative 2. But as a fraction, that would be negative 2 over 1. And I always like to write the negative 2 on, so the negative sign on top if there's a negative there. But you could write it on the bottom, but sometimes it gets a bit confusing what that's telling you. Okay, so where do we start here? We started at 4. That's our y-intercept. So I go up to 4. So 1, 2, 3, 4. That's 4 on the y-axis, the y-intercept. And now my slope is negative 2 over 1. So notice that when it was up here, when it was 2, it became 2 over 1. You went up 2 over 1, or you went 1 to the right and then up 2. But now that it's negative, you're going to be going downwards here. So a negative slope means you're going downhill. So I'm going to go down 2 over 1. So down 2 over 1. Down 2 over 1. Maybe I'll just draw that in. So I'll use a different color. Let's use, I'll use that orangey color. So down 2 over 1, down 2 over 1. I guess I go down 2 more over 1 again if I really want to. And what you'll notice is no matter how many times you go down 2 over 1, these 3 points all fit on a line here. So if we flip that around, and now I draw my line through there. Get rid of that. That would be, maybe I'll call this number 2 line. I call this number 2. Actually, let's use letters because I've got lots of numbers around here. Let's call this line B, and this is line B. And then line A, we'll make this one, just in case people are watching this video aren't listening to what I've said here. Okay, so there's our 2 lines. You get this kind of cool X in the middle here. Okay, so let's try one more line to see if we're okay here, and then we'll wrap it up with one last little topic here. So let's take a look at where to go. Let's go green here. Okay, so let's take a look at line C, and I'm going to make this y is equal to 2/5 x. And I'll just say that 2/5 x. There we go. Leave it like that. Okay. So once again, try to find your y-intercept. And try to find your slope. Okay, so notice that the y-intercept is always the number that comes after the x. It's sort of the plus or minus number on the end there. So I'm just going to shade that in the question above. So there, that 4 was the y-intercept. So really, we should be looking there to find our y-intercept. So if there's no number there, oopsie, who's that? Oh. So if that's the equation, then it must be plus something that doesn't show. So it must be plus 0. And that's the only thing that would give us that initial statement. So our y-intercept is actually at 0 here. So there's no number there, then it means it starts at 0, the origin of the graph. So the slope of the line now, that's the 2/3. So the 2/3 here would be the slope. Now, I'm going to use some proper language here that's going to relate to the formula. So what we actually use is words rise over run. And the slope of a line is always considered to be the rise divided by the run. So the top number is always how much you go up by, and the bottom number is always by how much you go to the right by. So up to over 3. So I go to my graph and I say, well, I got to start at 0. That's my starting point. And now I have to go up to over 3. So I'm going to get rid of some of these yellow lines here because it's kind of hard to show all this. Okay, so I'm going to go up 2, but then I have to go right 3. So I'm going to have a point 1, 2, 3 there. Okay, and then I need to go up 2, rise 2, and then run 3. And once I have my 3 points, I should notice that they're all in a line. So the reason I get you to do 3 points is if you make a mistake, then you'll easily see it. They won't fit on a straight line then. And if you did 4 points, it would be even more clear. So this line has a y-intercept at 0 and a slope of 2/3, meaning it goes up 2 over 3. A little bit off there, but I think you guys get the idea. And the line just keeps on going. That's why we put arrows on the end. So the line never technically ends. It goes on forever. Okay, so there's our how we graph lines from an equation. So what I want to finish off here was the sort of the general notes on this. This is sort of how we look at graphing lines. And one of them is putting the equation in what we call slope intercept form. And that's just sort of a fancy math way of saying that once we write the equation in a certain way, you will know the slope and you will know the y-intercept of the graph. And so this is always written in the form y equals mx plus b. You might remember b from yesterday. B will be the y-intercept. And m, that will always be the slope. And the slope is defined to be the rise over the run. And so if the slope is positive, so if you have a positive value, then the line will sort of point in that direction. And if the slope is negative, the line will always point in a downwards direction as you move to the right. So that's our formula here. And so just to show you this, it wouldn't matter what country you lived in right now. If you learned slope intercept form and someone wrote this equation, say negative 3x plus 5, and they just said to you, where is the slope? Anybody who knows this formula would be able to say it's 5. Sorry, where's the slope? Sorry, the slope would be negative 3. Sorry, negative 3 or 1. If they said, where's the y-intercept? They would say, well, it's at 5. That's the y-intercept of the function. So the b value is the y-intercept, and then the m value is the slope. And just one more thing on defining slope, and I'm going to do another video on this. So I'm going to do a real quick crash course on this, but this next video will be more specific about how this works. So rise over run. And when you guys get older, many of you might take physics 11, maybe even 12, chemistry 11, chemistry 12, or biology 11, biology 12, and you'll actually be graphing stuff where you have to figure out the slope of things. And so the rise is referred to as, sometimes written as delta y over delta x. So the symbol is called delta, and it means change in. Means how things change. And the actual definition of this is you take y2 minus y1 over x2 minus x1. And so I'm going to show you how you can find the slope of a line by using this formula if you were given the graph, say. So I'm going to do one more example question, then we're going to call it quits for the day. Okay, so control V. There we go. Okay, so if you guys can just take a second to draw this this picture here. Let's see, let's put a point here, and a point over here. And we're going to draw a line through these points. Okay, now there's a couple ways to do this, but I'm going to show you how to use the slope-intercept form to figure this out here. So if we look at these 2 points, let's call this point A and this point B here. So I'll write A. And I want you guys to write the coordinates of point A and the coordinates of point B here. Okay. Well, point A seems to be located at 1, 2, 3, 4. So it's -4. And then 1, 2, 3, 4. So I'm going to say it should be -4 on the x and 4 on the y. And point B is 1, 2, 3, 4, 5. So 5 on the x and -1 on the y. So if I use the formula for slope being y2 minus y1, dividing it by x2 minus x1, then what I'm going to do is subtract these numbers in a way that gives me the slope. But before I do that, I might just look at the picture and think, should my answer be positive or negative? Well, it's a downward slope, so it should be a negative number when I'm done. Now, it doesn't matter which point you make, point 1 and point 2, but you have to be consistent. So for example, if you make point A, if you make this point 1, then this is x1, y1. That's the coordinates. And if you make this point 2, then that's x2 and y2. And you could mix it up where you make A point 2 and B point 1, but you have to have x1, y1 associated with the same point as point 1, and x2, y2 associated with point P2. So what I'm going to do now is take the numbers on the picture, and I'm going to say A is, that's x1, this is y1, this is x2, and that's y2. So according to the formula, I take y2, -1, that's -1, and I minus point y1, which is 4. And now I take point x2, which is 5, and now I minus point x1, which is -4. And so I get -1 minus 4 is -5, all over, this would be 5 plus 4 now, because you're subtracting a negative, which would be 9. Which means my graph should go down 5 over 9. Let's just check that. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it does do that. It goes down 5 and over 9 units here. So that's how we do slope. So if I was writing the equation for this line, I now know y equals -5 over 9x plus b. I don't know b yet. It looks like it's around there. But my other video, I'm going to show you how to do that, okay? So for right now, the main goal here is being able to read an equation and determine its slope and its y-intercept. So we're getting into graphing straight lines today. So I'm going to unshare the screen here, and